Greetings and welcome to the introduction to astronomy. In this lecture, we will talk about astronomy of the last 100 years. What has happened and what have we learned over the last 100 years? Note that I will have some lectures like this that are considered enrichment lectures, meaning that they do not tie directly into the class itself or to the textbook. I often use these in discussions or for other parts of the class or for just for students who want to learn a little bit more about certain topics. So let's go ahead and get started, and we will start just talking a little bit about that astronomy has changed. And we have learned so much more about stars and galaxies and planets over the past 100 years. So many things that we know today that we had no idea about just 100 years ago. General relativity is an example, something we won't talk about here, but it's only a little over 100 years old when general relativity was first published. And that is our current understanding of gravity. So we're going to look over the coming slides a little bit more detail about what we have learned over the last 100 years. Move into the 1930s. We see Clyde Tombaugh here, the discovery of Pluto, now one of the 5 dwarf planets known in the solar system. So that was the last time at that point, it was the last time a planet had been discovered. And of course, now that is no longer classified as a planet. Now, a few years later, Carl Jansky built the first radio telescope detecting radio waves from space and opening up the field of radio astronomy. This is important because it's a new view on the universe, a new way to see the universe through a different type of electromagnetic radiation. Prior to this, everything had been simply visible light. In 1933, we had the idea that a neutron star that would form in a supernova collapse, and at the center of something like the Crab Nebula here, a neutron star could form where all of the material in an atom is pushed into the nucleus and therefore crushed together under enormous pressures. Now, while this was the theory of it, the actual detection of it will not come for another few decades. And Hans Bethe gave us the method that describes how stars are powered through hydrogen fusion into helium atoms. And that was how the stars were getting their energy. It was 1938 that we learned how the stars got their energy and were powered. Before that, there were various methods that were considered, but this was the one that we have that finally has stood the test. And now we understand that this is how stars like the sun produce their energy. Now, as we move forward a little bit more, let's look at the 1940s, after World War II. Now, the completion of the Palomar 200-inch telescope, which was the largest telescope in the world for over 3 decades. And of course, now we have many larger telescopes than this, but this was still a tremendous accomplishment and the very largest telescope for 30 years. Jumping ahead almost another decade, we start to head into the space age, and Sputnik 1 was launching the first satellite into space. And that followed closely on just a couple of years later. Luna 2 and Luna 3 explored the moon, one crashing into the surface, a Luna 2, and the other imaging the far side of the moon as seen here for the first time in human history. It was the first time we had ever the distant side of our nearest neighbor in space, because the moon always keeps one side locked toward Earth. In 1961, we had the first humans to orbit the Earth. Here is the memorial for that. And we're beginning in, again, the details of the space age and detailed exploration of planets from beyond just Earth. So in 1962, we had the first craft to visit another planet. Think about that. Just a few years after the first satellite was put into orbit, we already sent the first craft to another planet when Mariner 2 flew by Venus. Then in 1962, Martin Schmidt discovers quasars that are actually active galaxies. Now quasars were known, but they were thought that they could be stars. They were star-like objects. And now that we knew that they were actually distant active galaxies, we know that they are the most distant objects known in the universe. In 1965, Penzias and Wilson discovered the cosmic microwave background radiation using the telescope shown here to find the remnant of the Big Bang that created the universe. In 1966, we find the Luna 9 spacecraft gave us the first soft landing on the moon. So the first time a soft landing occurred on the moon, and other times we crashed into the surface. This was the first time we landed softly, preparing the way for manned missions coming up in just a couple of years. And by 1967, we see Jocelyn Bell pictured here discovering the first pulsar, which was that neutron star we discussed a little while ago, rotating very rapidly at the center of the Crab Nebula. The first manned flight to the moon, 1968, giving us this image looking out back from around the moon, not on the surface yet, but around the moon, looking back toward Earth, and in fact seeing Earth as going through phases just as the moon does as seen from Earth. A year later, we had the first manned landing on the moon, Apollo 11 landing on the moon here, showing the lunar lander, the American flag up there in the distance, and some of the equipment being set up here. Now coming into the 1970s, we had the Uhuru satellite, the first chance to look at X-rays from space. So we had visible light for a long time. Then we added in the ability to look in the radio waves. And now getting up above the atmosphere, we can see X-rays. And also in the 1970s, starting the satellites. So this is the Salyut 1, the first space station that was launched to study the universe from space. Now, later on into the 1970s, we had the identification of Cygnus X1, a well-known binary star system consisting of a massive star and a dark unseen object. And it was identified and confirmed as a black hole in 1972. Now, in 1975, we had the first image of the surface of Venus seen from the Venera 9 spacecraft, which landed on the surface. And you can see a portion of that surface in our image here. Also landing on an object, 1976, you can see looking somewhat similar to Venus, but definitely some significant differences as well. And that is the Viking lander on the surface of Mars, looking for the possibility of some kind of life there. The following year, Voyager 1 and Voyager 2 were launched to explore the outer solar system. So we've seen some studies of our moon, Venus and Mars here, now heading out to look at the outer solar system. But before they got there, actually, we discovered that Uranus had rings that same year, and they would be studied in more detail by the Voyager 2 spacecraft when it reached the planet Uranus. In the late 1970s, we had the discovery of dark matter, or at least the confirmation of dark matter, that we had learned that some material was missing from galaxies, that there was more mass there than could be accounted for by the light and other energy being emitted everything that we could see. Now we also, again, expanding in our studies, we used the IRAS satellite to study the universe in the infrared. So studying out there, looking again at another part of the electromagnetic spectrum. Over the next couple of years, in the later 1980s, we visited Uranus and Neptune, exploring two more planets in the outer portion of the solar system. And as we'd seen an image of Venus from the surface previously, but Venus cannot be mapped from outside. So at least not invisible light, but map of Venus by the Magellan spacecraft, being fully mapped by radar in 1990. Now continuing on into the 1990s, we see the launch of Hubble Space Telescope to explore the universe in visible light from up above the atmosphere and getting above the blurring effects of our atmosphere. Also another satellite in 1992, COBE, the Cosmic Background Explorer, detecting ripples in the background radiation of the universe, telling us something about the earliest structures beginning to form after the Big Bang. That same year, we had the first confirmed detection of an exoplanet, meaning a planet outside of our own solar system. Up until this time, we only knew of the planets within our solar system. And while we suspected others might exist, this was the first confirmation of one of these. In 1998, we had the construction beginning on the International Space Station, shown here with its solar panel arrays for energy and different modules set up within the International Space Station in a low Earth orbit to conduct scientific experiments from space. That same year, we discovered dark energy. Dark energy was something that was found to accelerate the expansion of the universe. So we expected that the universe would start off with a big bang and then slowly slow down as gravity pulled on objects. But what we find is that things are actually accelerating and things are moving faster, and that acceleration will continue and the universe will continue to accelerate its expansion. Now moving on into the 2000s, we discovered Eris. Eris was discovered in the outer solar system. So we see that here pictured and its moon, not easy to see from Earth. In 2006, we came up with the classification of a dwarf planet, a formal definition of a planet, which is where Pluto's classification got changed. And we now have several of these that are actually classified as dwarf planets: Pluto, Eris, Makemake, and Haumea, and others which may be classified as dwarf planets as well. There are currently 5 dwarf planets known. Now, black holes, we had detections and determinations that black holes existed. We had one of the first confirmations, one of the first visual evidence of a black hole seen, in this case a flare around a black hole. So we're getting more and more detailed understanding of how black holes have occurred and more understanding of those. And we're going to see in 2013 an extrasolar asteroid, meaning that it is an asteroid not part of our solar system, but from another solar system that traveled into our system. So it was ejected out of its system, as much material is ejected out of our own solar system when it formed, and formed another traveled into, just happened to travel into our solar system. Moving on, we had the exploration of Pluto by the New Horizons spacecraft, giving us great detailed images that are still being studied of the distant dwarf planet. Also in 2015, we had the very first detection of gravitational waves from 2 coalescing black holes. And the gravitational waves occur when objects are moving, when any object with mass is moving. But the gravitational waves are strongest when that object moves fastest. So we need very high mass objects to be able to detect these very weak gravitational waves. And the first confirmed detection of them was in 2015, nearly 100 years after they were predicted by Einstein in his general theory of relativity. Again in 2015, the first confirmed Earth-like planet found to exist in the habitable zone of a star. So finding more planets that may be habitable. Existing in a habitable zone doesn't mean it is habitable, simply that it's going to be at the right distance for liquid water to be able to be present on the surface. In 2017, another source of gravitational waves from a neutron star collision was detected, first of all, in gravitational waves, but was able to be observed in visible and other wavelengths as well. So continuing the new field of gravitational wave astronomy. Now, as we come into the current more current things, we have 2019. The Event Horizon Telescope gave us this image of the black hole at the center of a galaxy known as M87. And we see the shadow of the event horizon of the black hole there, along with material around that black hole. In 2020, OSIRIS-REx, seen here, collecting a sample of the asteroid Bennu, comes down, grabs that material, sprays that material up, which is then captured, and then is going to return that to Earth. And that is scheduled for the later part of 2023. In 2021, we also had the Ingenuity helicopter flying on Mars. That came with the Perseverance rover. And that was our first time trying to fly through the atmosphere of another object. So not just going through to land, but actually traveling through to look, take images, and be able to study. Now, of course, getting up above the ground makes things travel a lot easier than it is with the rovers that have to worry about obstacles. So a chance to have a different way to be able to explore objects. And then in 2022, we had the DART mission. And that was an impact on an asteroid, or actually the satellite of an asteroid, to try to change its path. And it was considered a planetary defense mission. That could we actually change this? And it was found that we did change the orbit by about half an hour by the impact of a spacecraft on a much larger asteroid. So perhaps in the future we would be able to redirect an asteroid that was coming toward Earth. So that gets us almost up to date. And what we'll see summarize here, we talk about things like less than 100 years ago, we didn't really understand galaxies or what they were or how stars worked. Those are things that we talked about in this lesson. The space age gave us a revolution in discoveries in astronomy, and who knows what is coming next and what will be that next big discovery. So that concludes this lecture on a century of astronomy. We'll be back again next time for another topic in astronomy. So until then, have a great day, everyone, and I will see you in class.